Hi, everybody. Welcome to this week's SQL on Fire Analytics meeting. So this week we have John kicking off the Parquet on Fire workstream for 2025. But before we get to that, I'm just going to take a quick peek at the other work streams. We can chat about any of them. So Dev Days proposals, I think we've had a conversation about them. I haven't heard back at all from Rena Ward about it. And I think Bashir, you did you mention you submitted something? I'm kind of out of the loop, but thank you.
Yeah, I have two submissions. One is around the gateway work that we have, which is not relevant to this meeting. And the other one is related to SQL on Fire. So basically the idea is basically text to SQL on Fire. So it's basically, asking natural language questions from Fire server, basically, but through SQL on Fire. So it basically goes through, there's a lot of research doing text to SQL. So we basically try to build on top of that, but then we do Fire specific things in that.
Oh, that's really cool. That's awesome. That's fascinating. I'm sure you get into RAG and fine tuning and stuff like that.
Yeah.
Very neat.
And also code systems, understanding code systems, again, how you can, summarize it and then feed it to your LLM and things like that.
Oh yeah. Oh, that's going to be awesome. Yeah. And if you can share any of that pre Dev Days, would be fascinating, I think, for a lot of people.
Sure. It is in very, very preliminary stages. So, I know we are recording. We haven't started recording yet, but right?
I have started recording, so don't say anything.
It doesn't say recording for some reason. I don't know why, but anyway. Yeah, but the things that I have put in the abstract, so we are actually working on it. So it's not something it's ready.
It's too long of a cycle, right? Because it's so that's
by 6 months I have had everything.
Yeah, that's why all of our conferences for Fire Analytics, it's proposal 3 weeks before. That's what are you going to do, right? We do things differently here. Cool. No, that sounds really fascinating. Shoot, I'd be really interested in it. Obviously, I think a lot of us, not just in this group, but everywhere, is starting to kick around these ideas for 6 months or a year. So it's going to be awesome to see what you guys come up with. Using Gemma, I imagine?
So yeah, that's the other piece of it that, because our work is mostly focused on open source and especially low resource environments, like open stack is basically that's the focus. Eventually, we want to be able to do everything with Gemma as well. But right now, because I'm just experimenting, I'm just using the best model that I can. Using, my current experiments are with Gemini. But eventually we want to be able to reproduce those with Gemma.
Yeah, that makes total sense. Very cool. All right. So yeah, those Dev Days, we have a couple of outstanding to-dos. I think they're, relatively minor. Event schedules, I will eventually get to that, to start planning out some events and some of the marketing aspects over the next couple of weeks. Should probably check in with how everybody's feeling temperature-wise around milestone 2 and the spec and the API. This has been the focus for the past couple of weeks. Where do we feel sort of we're at with that? Definitely, I think we need more development work. But what would you say? This goes to the whole group. Would be sort of the next steps, next milestones for that work.
No, I think it's still early. The thing that I started doing was, the bulk sandbox application. So you can go to that website and you can sort of interact with the test bulk server. I kind of forked that and I was playing around with integrating our SQL on Fire reference implementation with that, just to sort of test drive some of the API concepts that we've been talking about, because I find it very hard to just stay in abstract land for too long. So I was hoping to make a little bit of progress on that before the next time that we talk about it. But yeah, I think we've still got a long way to go. And as you say, the implementation part of it is really important.
Okay. Yeah, no, that makes total sense. I should actually probably go back through the notes. It's been a week and I've forgotten what the next what we had talked about as next steps. Obviously, Nikolai isn't here. He's really driving this. But yeah, I just wanted to open up to the group and get a feeling and sense of temperature of, where we can go next and what, folks in the group can help with. Gino?
Yeah, I just thought it was probably worth mentioning too. We did have a lot of discussion about the R6 versioning stuff. And right now, we're looking at things like logical models and being able to, in R6, directly insert those into bundles and things like that. so that people can keep iterating after R6 is published. So I do have that on my agenda to play with in a reference implementation, and ViewDefinition is the one I'm playing with in that context. So that way you can just add it to the API and see what happens in the context of V2 spec and everything else. Logical model so far is a good direction to go.
Okay, great. Yeah, and I know that that's been an ongoing stream of work, but yeah, just let us know and let the channel know how that works for us.
Yeah, and we can, Graham has done some additional stuff so we can base a logical model on, for instance, canonical resource and stuff like that, so we can inherit those properties and all kinds of weird stuff like that he's been working on. So I will take a stab at updating that as soon as I have a little more bandwidth.
Okay, awesome. Sounds good to hear. Anyone else thoughts on milestone 2 development? All right. In terms of the other work streams, query resource authoring, publishing, I haven't actually chatted with Brian about that, but I'll ping him this week, at least for the next couple of days. FHIR to OMOP. I know we've discussed it, but I don't know if we've really kicked it off or actioned it. But let's focus on what we have in front of us with John and then focus on those. So with anything else from the group at this point? No? All right. So Parquet on FHIR 2025. Turned over to John.
Let me just share my screen. Everybody see that? So just before we get into that, Gina, you were mentioning the work that Graham has done. I thought I might just quickly show that we've actually taken in the version of the IG publisher that now supports view definitions. And you can see that in the spec itself. So if you go to a view definition, it has like a custom rendering of view definition and runs it through the view definition validator in the IG publisher, which is really cool. The other part of that I would like to adopt in this spec is the integration with the SQL query part of the IG publisher. So the other thing you can do is you can render a table, which is the output of a SQL and FHIR view, which is based on resources in the IG. So I think it'd be cool if we queried test source resources in the using our example SQL and FHIR views and rendered out the result as like a sort of table that gets actually built at build time of the IG. And that would kind of complete the story of dog fooding the view definition stuff in our own IG, I think. But yeah, I'm really excited about this IG publisher stuff. Anyway,
Yeah, it's
So,
great.
quick
idea.
question, John, on that. So is the idea in the context of, IG publisher, is the idea that people as part of their IG, they may have like a specific view definitions that are relevant to their IG, and then this is better support for those use cases? Is that the idea?
absolutely.
Okay.
Yeah, the idea is that we have a sort of reference validator, I guess, and we also have support for like custom rendering of these things so that yes, you can bundle them into IGs and actually have them so people who use your IG have an easy way to use the data that you're defining, really, is what it's all about.
I see. And the validator, what's the stage of it? I mean, I remember a few months ago that I was fixing a bug in it. There were a lot of like warnings which were incorrect. Like, it wasn't processing, for example, for each property, the things that were inside for each and things like that.
Yeah, another thing on the to-do list, which if anyone, it's on my to-do list, but haven't got to it yet, is to fill out this column. So we need to add to the build process of FHIR core to just spit out a little JSON file that is the results of the SQL and FHIR tests, and then put it somewhere so that we can pick it up in this matrix. And then we can have surety that Graham's implementation is sort of ticking off all our tests. So that's another sort of task to be done at some point.
All
Okay.
right. So, yep.
Sorry, Arjun. Is that?
No worries. I just noting that. Is that a to-do in GitHub? Or I can add one if not.
Yeah, I think we may as well just have a GitHub there. I mean, it involves somebody working on the FHIR core side as well, though. So, okay, so Parquet and FHIR. let me show you my nice slide that I made. Oops. So what this is about is, there's been multiple sort of efforts in this area, and we thought, hey, why not get together and see what the differences are and see if we can figure out what the union of the use cases is and and can we actually harmonize these efforts. So we've actually got so far 3 different efforts, and I've done it well at least 3. There actually probably is more, but this is the starting point. And I've done a little bit of an effort to do a diff between these things, and I'm very glad you're here today, Bashir, so that you can fact check some of these things. And so over time, so obviously I've been working on Pathlink for quite a long time, and we have had a Parquet schema that can accommodate FHIR data for quite a long time. And it, like FHIR data pipes, has lineage with Bunsen, which was a library that was done by Ryan at Cerner back in the day. But it's also changed quite a lot since then, and it has been built to target slightly different use cases maybe than FHIR data pipes, and as a result has come up with slightly different answers to things. And I'm using some jargon in here that maybe doesn't mean much to you yet, but I'm actually going to explain it. So both Pathling and FHIR data pipes, they try to create one schema that can accommodate any data for a FHIR resource with caveats, right? So the first sort of stab at this is, convert, say, a structure definition, like a patient structure definition, into a big log schema with a place that contains all the different, data that a patient schema can have. And what that looks like, this is basically what a Parquet schema looks like. So it's really just a declaration of fields and their data types, but it can be obviously nested. So you have groups and you have lists or arrays. And so basically it's an exercise in taking a structure definition and converting it into a big long schema for a Parquet file. And then when you bring FHIR data in, you put everything in the right places. And then you can use an analytic tool to query it with SQL. However, you still have to do all the hard work with SQL, like unnesting and all the rest of it. Hence, we now have the SQL on FHIR ViewDefinition. So what both Bashir and I have worked on is creating a view runner over our respective engines to automate all this. But this is what the data layer looks like effectively for this type of query engine, which is more of a big data analytic columnar type of scenario. So what we're looking at here is a spec of the as-built in Pathling. Here's a spec of the as-built in FHIR data pipes, which has a lot of has more similarities than differences, but I'll talk about the differences in a minute. And then we have a new spec, which we've been working on, called Parquet on FHIR, which attempts to sort of create something a little bit more general, and maybe we could use as a basis for harmonizing this requirement. So both Pathling and data pipes try to create a big schema that can accommodate just about everything you need to store for that resource type. But then you get into things like extension content, so if you need to have this static schema, how do you accommodate extension content? And this is where the two start to differ. So with data pipe, and of course, Bashir, jump in at any time here if I get anything wrong here. But it effectively assumes a set of known extension types and promotes them to a top level field. So if you know about an extension, you can actually treat it like a top level field, and you can create fields for it, and you can query that really easily just by, like, say if it's ethnicity, you can just have an ethnicity field at the top level of your resource, and you can put the US core ethnicity schema into that, and you can just query it directly. However, that requires you to know that you want to use US core ethnicity, for example. Pathling took a different approach to that, in that it effectively supports undeclared extension content. And the way that it does that is that it has field IDs within the schema at the top level, which maps between field ID and the generic extension structure. So if you want it against a particular field, you connect to the field ID of that field to the map, and you bring that into your. So pathling can actually is almost lossless in its representation, but there's some caveats there. So one of the problems with the maximal schema is recursion. So FHIR structures are theoretically infinite in some cases, where you have, things like questionnaire. You can have unlimited levels of, questionnaire items and questionnaire responses. And if you're going to create a schema to accommodate that, you've got to parameterize that and say, I only want recursion depth 3 or something, which is kind of annoying. But you can, if you've got a data set and you know that it's only going to go to a certain level of recursion, or you just choose something that's beyond what's reasonable, then that actually works fine most of the time. And FHIR data pipes is similar in that way. So there are some tricky bits about round tripping FHIR data, and we'll talk about that in a minute, and data fidelity loss. Pathling actually doesn't support some resources because they've got really problematic aspects to them that make it hard to write a schema for them. I'm not sure if this is the same for data pipes, but anyway, so Parquet on FHIR actually attempts to address some fundamental issues here. So the difference with Parquet on FHIR is that as a spec, it can actually encompass either a maximal schema, or it can actually, you can still conform to it, but having a subset schema. So maybe you don't need the full schema for what you're doing. Maybe your data set doesn't require the full schema and you can use a subset of the schema. That's fine. And there's some trade-offs there, and I'll talk about it in terms of expectations about what's going to be in the table and all the rest of it that come into play then. But that's kind of how it works currently. It actually supports all extension content. So primitive extensions, which we never actually cracked in pathling, at least. And it is actually FHIR version agnostic. So you can have it can accommodate any version of FHIR by using like a superset of the data types. And it actually aligns very closely with the FHIR JSON structure, which has some advantages, including like using the JSON schema inference of certain query engines and that sort of thing. And finally, this spec has this feature that was inspired by some of the work Dan Gottlieb did a number of years ago called annotations, which allows you to sort of progressively enhance the Parquet representation with sort of derived information. So for things like optimizing query performance, or, and I'll talk about some examples of that. So any questions on that so far? I've just got a couple of slides just to talk about what I mean by some of these things, but let us know if anybody's got any thoughts or questions.
Yeah, just a quick note, I mean, and thanks for putting these together and then comparing. I mean, this is actually great. So I think maybe you are covering it in your follow-up slides, but I think also one thing which is to define what's our goal for defining like a Parquet and FHIR schema, because there could be like, different goals and have competing requirements. Like, I mean, do I want my query for an extension to be simple, or do I want it to be generic, for example? Do I want to, it's like, I mean, if my schema is fluid, then what does it mean writing SQL against that schema and things like that?
Yeah. So if I want to write some SQL and know that it can run against things that conform to this spec, then it needs to have some sort of solid expectations there. And this flexible schema thing is really just an idea that I had, but there's some trade-offs involved in that. And I haven't really got my head around how that should work, whether it should be like, again, like we did with SQL and FHIR, like a sort of profile architecture where we have different sort of profiles of this spec to suit different things. But you've got different use cases. Like maybe one use case is I want to just get a bulk extract from somewhere, but I want it in Parquet format because that saves me heaps of processing on both the generation side and the consuming side, for example. Or maybe it's more of like a sort of standard data lake format that I'm running queries over. I want to share queries, or yeah, it just depends on what you're doing, I think. But let me talk a bit about this maximal versus flexible thing. And sorry, I don't usually put all this text on a slide, but I haven't had a lot of time to prepare this. So as I said, the maximal has some problems because it's not actually strictly possible in FHIR, because the FHIR schema, like if you take the JSON representation of FHIR, it's actually theoretically infinite. Like if I just said, I'm just going to use the JSON representation of the patient resource. Okay, let's say not the patient resource. Like, well, it actually is still infinite in the patient resource because if you talk about extensions and that sort of stuff, so I can't really make a static schema that follows that perfectly. I have to do things like parameterize the recursion depth. In pathling, we also did things like what open types do you want? Because if you use like all 20 or whatever open types in every spot where there's a polymorphic type, then you end up with a schema that's, hundreds or 1,000 lines long sort of thing. And then it starts to impact performance and all that sort of thing. So the idea with Parquet and FHIR was, okay, well, could we actually just have a natural expression of the structure and a theoretically infinite schema, but instantiations of that just conform to that? And we don't necessarily have to use the super schema, if you like. So you can either have a totally static predictable schema with limitations, or you can have basically a perfect schema, but you can't rely on the fact that everything will always be there, right? So if we use a minimal or flexible schema, then the person who receives the data needs to be able to deal with things like the absence of fields and merging. So you might get one Parquet file that has some fields, and then another Parquet file that has other fields. And then you might want to put them both into a single table, and that's what we call merging. So then you kind of have to create the union of those schemas and make a new table with that data. And so I've done a bit of work on this. I've actually implemented this in a branch of Pathling to sort of validate the idea of, is it possible to actually be tolerant of these things? And it turns out that it is, at least in an Apache Spark implementation, which is admittedly maybe more sophisticated than, some other query engines that might be consuming this. So, but the advantage that it has is that you have really nice, efficient, tight schemas that perform actually a lot better. And the way that you effectively encode the incoming data is much simpler because we can use just JSON schema inference plus some augmentation to do it. So we actually, in that fork of Pathling, we actually deleted a lot of code. We can, and we're also able to get the benefit of this annotation stuff, which I'm going to talk about in a minute.
Yeah. So when you say, I mean, the basic idea actually, I think is very cool. Having just this kind of, fluid schema that could stop at anywhere for different fields and different resources, basically. So in your experiment, Spark has support that, you can, let's say, load two patient resources which have different levels of a schema. And basically you can just say, create like a joint schema. I think it has built-in support for that kind of thing. But I think like the question I have is that, if you write SQL against those, let's say, patient resources, and that SQL references some of the missing fields, does the Spark actually automatically handles this, like the SQL engine of a Spark?
No, it doesn't automatically build it. However, it's very simple in Spark because in Spark you can inspect the schema of a table effectively before you query it, right? So if I have a structure that I'm about to add another selection to my query in Spark, I can just look at the structure and say, what columns does it have? And that way, I'm actually not adding anything to the query, but I'm conditionally building it up effectively. So that's the way that Pathling works, is that, and you conditionally, yeah, I'm not sure if I'm explaining this up very well, but because the data frame is introspectable, you can do that quite easily. But you can also, so I think we need further proof of concepts with other technology to figure this out. But I would say that we can have multiple levels of capability here. So say Pathling is capable of taking minimal schema, and then we can build a maximal schema using the structure definition, and it slots straight in, right? Because the minimal is compatible with the maximal. So you can take data from the minimal schema and leave it as it is, or you can put it straight into a table which has a full maximal schema with recursion depth 3, and it will slot straight in, and you can pass that to a dumber client and it doesn't have to worry about any of that sort of stuff. So I think in that respect, you can kind of have your cake and eat it too. Like we could improve Pathling to have exactly the same expectations on it externally, but do this in a different way and have an option to not have the maximal schema on the way out and that sort of thing. So I think that it doesn't necessarily take away from the functionality, if that makes sense.
Yeah, I think I kind of got what you mean, but let's say if someone writes, I was mostly talking in the context of SQL, but even I think directly on data frames and let's say, I don't know, PySpark or whatever, if someone writes a query and it is touching a field that doesn't exist in a schema, are you saying that I can, before running that query, basically I can check the schema and I fail early? Is that what you mean? Saying that, this query cannot be run on this schema? Or are you saying that, I take that RK content, make the modification to the schema such that I can run that query, and, with little tweaking, I can support any query against the wide schema, against the maximalist?
So first of all, you don't throw an error, you just make it into an empty collection, right? So what you want is, if it's not there, you just want to return empty in terms of FHIR path land, right? So you want to be tolerant to it.
Let's say, another example is that, you are doing like a projection on that call. So let's say you are picking like a field, I don't know, gender, patient gender, for example. And then you can, in theory, fill all of the columns and then just put null in that output. You see what I mean? So it doesn't mean necessarily that, because this column is missing, your whole output is nothing. So it could have many rows and then all values in this column could be null.
Yeah. So maybe your data set doesn't have gender.
Right.
So one way of doing it is you put a column in the schema and you put null in it. And another way of doing it is you don't bother having a gender column at all. So depending on how smart your implementation is, regardless, or it requires the column to be there. Otherwise, it'll throw an error. So in the former case, you can you can create the maximal schema for it and give that sort of engine the maximal schema, and then it doesn't have to think about it. Does that kind of make sense?
Yeah.
But like I say, what we really need is, like we did for SQL on FHIR, a set of diverse implementations of this using different technologies and some actual worked examples of how this all might work. But I created a sort of, like I said, a full proof of concept branch and also like a really contained example of how the schema merging works in Spark, just to sort of prove out all of this. But it works pretty well in Spark. And as I said, like it actually allows us to unlock quite a big performance improvement in Spark. And it's also the basis for which we can do things like FHIR version agnosticism and also like data model agnosticism, right? Because, does your engine strictly need to follow the FHIR data types, or can you deal with arbitrary content? Like if I have an element called foo, what do I do? If I have an element that's in R5, but it's not in STU3, all that sort of stuff. We could build a more tolerant engine this way. Yes, you're on mute.
Sorry. Yeah, like you said, I think trying it with different tools is very important. Like, our vision in FHIR Data Pipes was that we generate Parquet, and we are agnostic of the query engine. So then, if you put gender 1 in your patient schema, then it's not consistent with the schema, like the schema framework that you have for version 4. You see what I mean?
Yeah, I do. And I'll try to think of a way to explain what I mean by that. But I don't, let me come back to that.
Yeah, I'll give John a set of time. One thing I was reminded when Bashir talk about the performance impact as well. I think it may actually be more than performance, because conceiving of some of these maximal schemas based on my experience when I worked at OneUp, they essentially it's not a maximal schema, but a schema for patient access. So that's US Core plus Karen. I think a fairly naive approach to creating a schema that covers that, and only one version of FHIR, maybe more. But that aside, it actually had, in some cases, this might have been improved. Some systems cannot support schemas of that size, period, right? Like they will not function. And so, I think the performance issues are important. And just going back and looking at some of the discussion around use cases and some thinking about how use cases in the past, performance and efficiency use cases here is a couple of different dimensions, of course, are going to be some of, I think, the most driving use cases, just from my perspective. So 2 points that I want to make. It's possible that systems are potentially not as sophisticated, won't be able to handle really large schemas, going into thousands of plus lines to begin with. And I think just generally speaking, in terms of where people are prioritizing use cases, performance is going to be quite high on the list, I think, for a lot of interest in this work. Yeah, Gino?
Oh, sorry. Yeah, I think there's a lot of overlap I do a lot of code generation stuff, and particularly things like OpenAPI. We have similarly, I don't know, I think we're up to almost 200 options for controlling the OpenAPI generation, because you need things like, do you want extensions on primitives? Do you want, how far do you want to nest? How, what kinds of types do you want to restrict to? All that kind of stuff. And then we get into code generation of things like profiling, and we talk about promoting extensions and slicing. And, do you want, when you look at observation, do you want to start separating out the category codes into the VS cat and, different things like that so that you can treat those as top level. So I put it down as a note here. I'm going to see if I can output it in CodeGen and see what kind of options start going in. But I have all that infrastructure there already. So we can add this as an export type and see what it comes out with.
What is the CodeGen? What's the inputs and outputs of the code generation that you're using?
I could put a link to the GitHub repo, but it takes in things like FHIR packages. So you tell it like FHIR R4, and then it outputs, and we have, I don't know how many languages we have right now, but it does like the underpinnings for the C#, the Firely SDK. It does the underpinnings it does all the generated stuff for the TypeScript, definitely typed. It does Ruby. It does, I don't remember how many different languages it exports now. And so it essentially takes in FHIR specs and profiles and all that kind of stuff, normalizes all the type differences, moves around all of the different weird extensions that we add for the internals, does all that, and then gives this exports general thing that essentially just write text files based on what you want. And so with OpenAPI and all those different languages. And so
Gotcha.
Servers and do things. It can read profiles. It can do all that. So
That's interesting.
It is written in C#. So since Nikolai's not here, he wants me to rewrite it in in TypeScript, but I don't it's a lot of code. So I don't particularly want to.
Well, now we have LLMs, so there's apparently no excuses for anything related to code.
That's also where I'm hosting. That's also where I do all the cross-version stuff I'm working on. It is terrible at that kind of detailed, finicky.
Oh, yeah.
Like, oh my gosh, it's so bad.
Yeah, I can see that. But, just wait a couple of weeks and see what happens. No, all jokes aside. Okay, yeah, that's helpful. I didn't know that exists. But yeah, I could see how it's rhyming a little bit, I think, with some of the issues that we're experiencing here.
Yeah, so Gino, I can imagine that tool potentially being used to produce a maximal Parquet schema for a given version of FHIR, actually. But yeah.
I was thinking of using it for a SQL schema as well. So
yeah, same sort of thing. Like you could that's like an abstract schema that you could use like as a Parquet schema or a number of things actually. But yeah, good idea. Before I forget, there was two things I wanted to address from what Bashir asked. So performance. The reason I think it affects performance in Spark so much is because the schema in Spark actually gets generated into code, right? So if you have a 1,000-line long schema or a 2,000-line long schema, it effectively becomes an expression in Spark, which is effectively generated code, which effectively gets shipped across between all the different workers at query time a lot. So it actually massively increases the sort of payload that's being passed around in order to distribute the work of the query. And if you can make that more compact, I think it just reduces some overhead there. So there's that. Now I'm struggling to remember the second bit, but I'm sure
the version differences.
Okay. Yes, so I committed the cardinal sin of drifting from the abstract to the concrete there. So I was actually talking about inspiration that this approach gave me to improve the implementation of pathling to be version agnostic at the implementation level if you take this sort of philosophy. However, you're right. Any given schema is necessarily version specific. However, one spec, many FHIR versions is what I'm contending. Right. So the spec kind of provides the rules for which you create the schema. but those same set of rules can be used for any FHIR version. So this spec, and the rules about repeating elements, choice types, complex types, I contend that they all generalize to all FHIR versions. So the rules stay the same. Does that make sense?
Yes. So basically, yeah, I mean, you are saying that, there is a way that to generate the schema which can work for any FHIR versions.
Yep.
And sorry, because we are almost out of time, just a very, maybe quick dumb question. Does anyone care about primitive extension?
I
I've
think,
never seen one in the wild.
I think the biggest problem are things like data absent reasons that, especially if you're pulling in a lot of legacy data, you might have a primitive that has a DAR on it, and you might really be interested in that.
I see. Okay.
Yes. I think sadly, primitive extensions have been adopted in various places, including like some of the Australian implementation guides. So unfortunately, we have to deal with them, and they can be a little bit tricky for the maximal approach, because I mean, you can totally put an optional primitive extension against every field, but again, then you've ballooned out the schema size to, again, maybe double or triple what it would have been. So it's just that sort of explosion of possibilities there. So if you just do it the way that the JSON format does, then it becomes very simple, because there can be an extension field anywhere, right? You need to have a maximal schema that's kind of enormous. And like we said, you can have it both ways as long as you limit the generation of the maximal schema. But it's also possible, I think. And I do think that this is possible beyond Spark, by the way, but I need to prove that. I recognize that. I think it's possible to have slightly smarter ways of querying this that don't require that. And I think it's worth investigation. We've done a lot of work on the maximal side of things, but this is like another sort of stream of investigation. Yeah, so just quickly, philosophy to data loss, so the other thing I wanted to figure out is it possible to have zero data loss? And what are the problem areas in FHIR? So we have a JSON representation, which itself is potentially lossy. We can't really solve that, but we can limit it to that, right? So, for example, if you take a decimal number and store it in a numeric data type in Parquet, you've lost data, right? Because that decimal, it has a precision and a scale that it was captured at, etc. So, and dates are similar, there are, you can, if you take that and you convert it into a native date time, you've lost precision, lost fidelity, sorry. And can you actually take FHIR, put it into Parquet, and then generate the exact same FHIR again? So that was one of the design goals with this, is to, through the use of annotations, preserve the original data and then optionally annotate it with things like native types so that you can do efficient querying and smart querying, but still have a way to bring that data back out into the original FHIR. So that's something that the existing implementations can do to a point, but it wasn't, I don't think, the primary goal. So I've kind of really promoted that to be like a design goal of this. And the way that that's done, I'm running out of time, but we'll have to continue this, is that effectively a lot of these problem things are stored as strings, but then annotated with native types. So for example, decimals and dates have a primary storage of string, but then we have annotations that can bring a derived form of those into native land, if that makes sense. But I might just stop there in the interest of time, and we can continue this.
Yeah, thanks, John. Of course, I think this is really helpful. just to refresh everybody's memory about all the work you did last year, which is awesome work. Start off with this again, maybe not to this and let people know that they should, take a look at the spec. But if you're good with that, yeah, I'd like to, keep this up during this meeting next week.
Yeah, I mean, as you know, I'm all about implementation. Like, I feel like we need sort of second proof of concept. Like maybe using an engine that's Parquet capable but is different. For example, like DuckDB perhaps, or if anyone's got any other ideas on that. But it would be great if, for example, we could get DuckDB to produce different variations and query over different variations of this schema and see what some of the considerations might be there using something that just uses pure SQL and its sort of version of traversing down into these structures to see how far we can get with that. What are the sort of clients that you need this to work for, Bashir, in terms of your goal of, producing something that anyone can query?
So, yeah, I mean, before answering that question, I mean, just like a quick proposal, since you have done a lot of work at, experimentation, maybe one idea is that if you can generate from synthetic data some sample Parquet files, like, I mean, let's say 2 different schemas for patient and observation or whatever, and then just put it somewhere such that, people, instead of, just skip going through the process of generation and then start experimenting with those Parquet files in their own tools. That can probably help up, speed up. And by the way, thanks a lot for driving this work. Now, regarding your question and our vision when we started this work was that people will put Parquet files in whatever tool that understands FHIR. And we just gave example, using it through Spark and then maybe uploading it to BigQuery, for example, things like that. These are the particular cases that I have worked with. I have done some experiments with DuckDB as well, with the wide schema, and the performance was really, really bad. And there is a notebook in our repo under query, which actually it documents the experiments that I have done with DuckDB. So, like, I mean, that was actually one of the reasons we were excited about doing SQL on FHIR, like the V2 spec, and then export to Parquet, because that's like a flat Parquet, which seems that, DuckDB can much better handle.
Yeah, if you could post those examples, I think Bashir, post those examples in those notebooks that, revealed that kind of performance issue. I think that's something that probably people aren't aware of. So that would be a great thread, I think. And then in terms of generating samples, if that's something that you can do, John, you might have that might not be such a big lift, but just get people to sort of work on their own. It's kind of hard to get people involved necessarily like in real time, but, make it easy for them to just play around with samples. I think that's another great idea. And then, focus on implementations, and we can, as a group, try and get people to get interested and start playing around with this with different systems. So yeah, I think those are really good next steps.
Yeah,
Cool.
I mean, Dan's already done a DuckDB implementation that works on FHIR JSON data, right? So that's flat crack. So I wonder how much of a change it would be to have that looking at sort of a similar structure in Parquet or minimal, maximal. Yeah, so maybe that could be a starting point if we were looking at the DuckDB side of things.
Oh yeah, for sure. We should call him out. I don't know what his workload is right now, but doesn't hurt to add him and see where he's at, and then get more people involved. And because people are excited about using DuckDB columnar data stores with FHIR. So okay, I think that's a good starting point. I think we've got a couple of to-dos and next steps, and we'll maybe do at least partially next week. Touch base on this. Does that sound good?
Yeah, cool.
All right, great. All right, good seeing all of you. All right.
Sorry for running over.
Thanks, John. That was good stuff.
No problem. See you next week.
Cheers.
Have a good week. See ya.